Hi friends! Today we're gonna talk about Mendel and the gene idea. Gregor Mendel discovered the basic principles of heredity by breeding a garden peas. He is not a good teacher, but he is a great scientist. He entered an Augustinian monastery at the age of 21 and left after 8 years for science. His family worked in a farm, so I can say that he knew about pea a lot. He had many reasons for breeding peas. So why did Gregor Mendel choose a pea for his experiment? Well, firstly, we don't need much time for weeding their offsprings. And secondly, they have many varieties. Well, let's start with the first experiment of Gregor Mendel. He was breeding two peas with the same character but the different traits. So, in order to start his experiments, firstly he removed stamens and pestils from each self-pollinating flowers. And then he took pollen from one flower and gave it to other. He carefully placed pollens to the pestle. After offsprings grew up, all of their flowers were purple. This is the first generation. We can't say that the purple color is dominant trait and white color is recessive. Fertilizing them to each other, he got second generation. He was surprised after he found white flowered peas. The proportion were approximately 1:3. This experiment proved his first law of segregation. His next experiment was with the seed. When he crossed these seeds, he got first generation. As you can see, they have two characters. So before he will cross first generation's member, he should predict what phenotype he will get at the second generation. That's why we have two laws. First one says that the genes are dependent on each other, so we should predict results as in first experiment. However, law of independent assortment says that these two genes of two characters are not dependent on each other. To prove this, we will use Punnett square. We will use a letter to show genotype of the seeds. Capital letter Y will show a dominant allele of yellow color, and capital R will show us a round shape of the seed. So that's why other letters are recessive. We have 4 variants of gene pair because of independent assortment. Any combination with at least one dominant by color and one dominant by shape will give parents character. In contrary, recessive alleles will give us other traits. But what will be with other traits? For example, if a combination have a recessive allele by shape, it will be a wrinkle. But if it had at least one dominant allele by color, it will be a yellow. The same logic for others. The proportion is 9331. After he crossed a heterozygote, he got approximately 9331 proportion. And this experiment proves law of independent assortment.